Hello and welcome, Mr. Callan here to help you with the assignment for May 20. You are almost there, ladies and gentlemen. May 20 called Compare Irrational Numbers Day 2. Yep, we have a quiz on Friday, so the most important thing to know about this, if I go to today's overview, is that the assignment's going to be due by Friday. You really should be doing it today, Wednesday, May 20th. But there's no point practicing something after quiz day. You want to practice it, you want to get some feedback, you want to learn, grow, attack your weaknesses, and build your strengths. So focus today, again, is comparing real numbers. However, you might see scratched out is we're not going to use a calculator today. We're going to go all number sense. So here we go. Just to review what we've been talking about in terms of number. In looking at the kingdom of number, we start counting our fingers, natural numbers, whole numbers. We learned that numbers have opposites. We call that set of numbers integers. We can compare numbers, which number is bigger, which number is smaller, greater or less. We can also estimate, especially with crazy, ugly, irrational numbers. Pi, we often use 3.14, something like that. Now, again, as just mentioned, we can compare numbers. If you have two numbers written as ratios or fractions, you can get common numerators, or in this case, we got common denominators. If you have decimals, some of you are a little more comfortable with decimals. We can compute numbers by putting them in the same form, either both in fraction form or both in decimal form. Of course, if you have problems where you have a crazy, ugly, irrational number like the square root of 74, we've learned how to estimate that number, a little bigger than 8, a little smaller than 9, closer to 9, so we can estimate the square root of 8. Square root of 74, about 8 6/10. Now, what happens if you have something crazy like this? Well, we do know that pi is about 3.14. So I guess we could just simply say, forget about all those decimal places. It's going to be about 3 holes and 1 hole. It's about 4 holes and 14 hundredths. Again, not perfect, but about. So we keep exploring number. How can we compare or compute with numbers? With rational numbers like decimals or fractions, not so bad. But when it comes to irrational numbers, we just have to estimate, come up with a really good rounded guess. So we head to today's assignment, where I'm going to very quickly just blot out all the answers so I'm not looking straight at them. And I will do all the I'll tell you what, I'll do 1 through 6. I'll do the entire left side for you right now. Directions say, for each pair of numbers, circle which is larger. Oh, and by the way, no calculator on today's assignment. And yes, it does say to write a sentence explaining your reasoning. I don't need a paragraph. I don't need a half a page essay. We should be able, however, to write a sentence explaining our thought process. So I'm going to go ahead and start with number 1, where we're trying to figure out which is larger, square root of 65 or 7 95/100. Now, the first thing I'm going to do, I'm going to come up with a reasonable estimate for the square root of 65. We know by now that 64 less than 65, 65 less than 81. Why did we choose those numbers? Well, now we can simplify these two perfect squares. The square root of 64 is 8, square root of 81 is 9. So the square root of 65 is somewhere in between. It's going to be about 8 point something. Now, I'll tell you what, let's at least go to the hundreds place and just come up with a decent estimate. If I look at 65 to 64, it's only 1 down. But if I look at 65 to 81, it'd be 16 up. It is clearly much closer to 8. In fact, it's so stinking close, I'm going to call it about 8 1/10. Well, just from that, we can immediately identify which of these numbers is greater, and it asks us to circle. But now let's go ahead and write our sentence. So I'll just go ahead and use the text box function over on the left, and I'm going to write the square root of 65 is about 8 1/10, which is clearly greater than 7 95/100. Another way of saying it, square root of 65 is bigger than the square root of 64, or 8. It's bigger than 8. 7 95/100 is less than 8. So let's go on to number 2 with the same idea in mind. Let's go ahead and try to figure out which of these numbers is larger. But first, I'm going to go ahead and try to figure out, what do we know about the square root of 101? Well, 101, a little bigger than 100, a little smaller than 121. Some people are still wondering, well, where did those numbers come from? Well, we can rewrite the compound inequality in such a way to find that the square root of 100, which is 10, is a little smaller than the square root of 101. The square root of 101, don't know exactly what that is, but I do know it's smaller than 11. That tells us that it's going to be about 10 point something. Once again, we see it is only 1 away here, but it's 20 away here. So it's really stinking close to 10. Maybe we just say about 10.1. So right from there, I can identify which of those numbers is greater. Let's go ahead and write our sentence, something to the effect that if the square root of 101 is about 10, that number is going to be less than 10 5/10. Number of different ways to say this, ladies and gents. Come up with your own way to say it when you do the other problems. But let's continue on with number 3. Again, no use of a calculator here, just our number sense. This says what is the cube root of 64 versus the square or second. Well, right away I'm going to write very lightly. If you don't see a number above that radical sign, it means a second root. So let's go ahead and remember what it means to take the cube root of some number. The cube root of a number means what times itself, and you should see 3 of the repeated factors. Now, please don't jump and say 8, because naturally 8 times 8 times 8 is going to be, well, it's going to be in the hundreds. That is way too big. But what we do know is that 4 times 4 is 16. 16 times another 4 works. Therefore, the opposite of the cube root of 64 is the same as saying the opposite of 4, or -4. Now let's go ahead and examine that in comparison to the opposite of the second or square root of 64. Well, the square root of 64 is 8, and the opposite of 8 would be -8. Now remember, we're comparing negatives here. Which of these numbers is greater? Not that either of these numbers is a good amount of money, but if it were money, I would much rather have the opposite of the cube root. I'd much rather have -4 in debt than -8 in debt. So we're going to go ahead and we're going to write our little sentence to explain ourselves. And so my sentence will say the opposite of the cube root of 64 is -4, while the opposite of the square root of 64 is -8. And because -4 is closer to 0 and closer to all the positives, -4 is greater than -8. Let's carry on with number 4. In fact, if you want to, you may pause the video and go on and try to do the right-hand side. That would be 7 through 12, I believe. Meanwhile, I'm going to carry on. I'm going to compare 9 and 5/100ths to 9 and 58,000ths. And of course, many of you by now are used to putting in the 0. So just pay attention to this. If you look closely, you'll see that they both have 9 holes. They both have 9 whole dollars and 0 dimes, 0 tenths. They both have $9.05, 9 and 5/100ths. But the most important piece where you finally see the difference is at the very end. If this were money, yes, it's only parts of a dollar, but I'd rather have that than no parts at all. Therefore, we're going to identify 9 and 58,000ths as the larger amount, and our sentence will say such. And so my sentence points out that while both have 9 holes, 5/100ths, only the one has the extra portion, the extra piece, the extra parts of pennies, the extra 8,000ths, thus it is greater. Moving along to number 5. It appears that the formatting doesn't look okay, but here's what we're comparing. We're comparing -2.5 versus -2.5 repeated. If I were to rewrite those both in decimal form, I prefer decimal. You're welcome to do it in fraction or mixed number form. A half naturally is 5/10. But if we have -2.55 repeating, and honestly, we can kind of forget about that repeating part. As soon as you see that while they both share -2 and 5/10, one has more parts, the other doesn't. However, be very careful and notice that this is in negative form. So if we go to -1, -2.5, and then -2.5, -2.5 is going to be greater than -2.5 repeated. So I'm going to go ahead and circle that one, and my sentence is going to point out that that one is closer to 0. While I write my sentence off to the side, I will point out in purple off to the left, some people prefer comparing numbers in fraction or mixed number form. Now that will necessitate you to change 0.5 repeated into 5/9, negative 2.5 repeated into negative 2 and 5/9. And of course, to compare fractions or mixed numbers. Some of you might forget this, but to compare fractions or mixed numbers, you want either a common numerator or a common denominator. Most of us choose common denominators. So you can compare negative 2 and 9/18 to negative 2 and 10/18. You can change them in improper fractions, negative 45/18, negative 46/18. Don't know why I put that negative down there. And see that clearly one is closer to 0 and the positives than the other. Let's carry on with number 6 and get back on track. Comparing 3/4 to 0.8 repeated, 3/4 being the same as saying 75/100, 0.8 repeated. Yes, we can have parts go on forever, but at this point I would forget those parts and just compare these two amounts. So with that in mind, you can clearly see that 0.8 repeated is going to be larger than 75/100. And we'll write a sentence to match that and explain our reason. So if you follow me for this far, why don't you go ahead and do numbers 7 through 12. Don't forget, if you wanted to mark out your answers, mark out the answers I put in there and then erase those to check your work. And don't forget the sentences explaining it. You can guess which one is greater half the time, but what's the point guessing and not really growing with your number sense? So go ahead, carry on with number 7 through 12 and come on back to the video when you're ready. Let us now continue on to the back side. I tell you what, I will do the entire top portion and you do the bottom. Let's go ahead and look at our directions. And here again, we see we are not using a calculator, but what we are going to do is we're going to label approximate locations for the following numbers on the number line. Each of these we're going to go ahead and pop on our number line. And it looks like the number line doesn't have any labels, so I'm going to go ahead and start off by labeling it. Let's see here. I'm going to put 0 in the middle. It appears that the smallest number is about negative 3, so let's go to negative 4 just to be safe. Negative 1, negative 2, negative 3, negative 4. And then we'll try to match that with positive 4 and hope that that works out. If not, we can erase it and go back and redo it. Goal is to label and put each of these numbers on the number line. So let's go ahead and start with point A, which is negative 3 wholes and 1,000. Now, if I pop to the left, negative 1, negative 2, negative 3 wholes. But listen, we're not just at negative 3 wholes. We are going a little further than that. So I'm going to try to place my dot just a little to the left there, and I will now label that dot as point A. That's all you need to do. Now let's do the same thing for negative 2 and 5/9. I'm going to go to the left, negative 1, negative 2, 5/9. Well, I might first try to figure out what decimal that is. So I'm going to say, let's change this to an improper fraction. 2 wholes, 9 slices each, 18 slices, and another 5 is 3. So let's go ahead now and divide 23 by 9. You can put as many zeros as you want. You just make sure your decimal point is right there. Now, not surprisingly, there's going to be 2 wholes, 2 nines is 18, 5 left over. That's not surprising either because we had 5 portions left over. Let's bring our 0 down. 9 goes into 50 5 times, leaving us with 5 left over, and 9 goes into 55 times. And by now, you might see a pattern here where we're going to have negative 2.5 repeated. What that does is that tells me exactly where on the number line it should go. If 2.5 is right in the middle, negative 2 and 5/10 might just be a little bit closer to negative 3. So let's go ahead and plot our point right there, and we will label that. Why did I do D next? Sorry, ladies and gents. I don't know why I did that. Let's continue on with point B. Be nice to have a nice accurate guess for the square root of 15. So let's find our bookends here. The square root of 9 is 3, the square root of 16 is 4, and the square root of 15 I don't know what the square root of 15 is exactly, but I do know it's going to be about 3 point something. Now let's go ahead and at least come up with the tenths place here. So if I review where I'm at, 15 is about 6 away from 9. It's only 1 away from 16. So we're talking really stinking close to 4. I might even say 3 and 9/10. Could be even 3 and 95/100. Who knows? But what that's going to do now is that's going to tell me it's just a little before 4. Almost might even look like it touches 4. And let's go ahead and label that point as point B. Running out of space here for C, so let's go ahead. Well, you know what? This one ends up quite nice because I know that the cube root of 8 is 2, and the opposite of 2 is -2. Ooh, that one's going to be very quick to plot right there, smack on -2. Let's go back and label that as point C. So I went a little out of order. I already did point D. A, B, C, D. That leaves point E. Oh, point E is 2.5. 2 and 5/10. Some of you might change that and rewrite that. I'm not saying you have to. Whoops. But that should tell us where to quickly plot point E. And don't forget to label it. So what we do is we're using our number line to just approximate it. And if they didn't ask us to put this in order, but we could say A is less than D, which is less than C, which is less than E, which is less than B, just by either making small decimal or fractional estimates of these amounts. So with that in mind, I just helped you with the full top part. You're going to go ahead now and do the bottom portion, A through H, and plot the numbers and label those numbers, label those points, A, B, C, whatnot. If you need to, come up with an estimate first so that you can more accurately plot those. All right, folks, hey, listen, I gave you my best. I'm asking you to do the same. Give me your best. Let me know. Let me know if I can help. Just email or message me, and do well.